So we're going to talk now about demonstrating equivalencies. Two sentences that are equivalent are sentences that are pretty much the same as far as logic is concerned. It means they're true under all the same circumstances and false under all the same circumstances. Of course, one way we can do this is to build a giant truth table and show that, for sentential logic anyway, show that everywhere that one sentence is true on the truth table, so every row one sentence is true, so is the other, and every row that one sentence is false, so is the other. So they're true and false on all the same rows of the truth table. Another way to do this, and this is the method that for practical reasons we're going to have to use for sentences of above a certain complexity, is to go ahead and use the SD system and show that one can be derived from the other and vice versa. So that's another way of showing that sentences are equivalent, and that's what we're going to look at now. So we want to show that if A or B, then A, and if B, then A are equivalent sentences. So we're going to start by showing that we can derive if B, then A from if A or B, then A. So what we're trying to prove here is a conditional. And we're going to go ahead and then we're going to start by assuming the antecedent of the conditional, or assuming B. So we're assuming this for purposes of conjunction introduction. And now on line 3, we want to be able to use this to get A. We're trying to get A in here, right? So we can conclude that. We can use disjunction introduction to get the antecedent of this conditional. So A or B follows by disjunction introduction on line 2. Now we get line 4 by conditional elimination, lines 1 and 3. And now we can conclude that if B, then A are a conditional introduction from lines 2 to 4. All right, so that completes this derivation. Let's move over to the other one we have to do. If B, then A, therefore A or B, then A. So this one's just slightly more complex. But again, we're trying to prove a conditional. So we should go ahead and start by assuming the antecedent, A or B. So we're doing this for purposes of conditional introduction once again. And the strategy that suggests itself now is to use disjunction elimination and check that we're trying to show that A is going to follow, right, the consequent of the conditional. And we want to show that if A, then A, and if B, then A. So let's start by assuming A. It's an assumption for purposes of disjunction elimination. And obviously, on the assumption that A follows. So we're going to use the reiteration rule from line 3 to show that explicitly. And now, on line 5, we're going to assume B. We want to show that A is going to follow from B as well. So again, B is an assumption for disjunction elimination. And we get A right away from conditional elimination lines 1 and 5. Okay, so A follows from disjunction elimination on lines 2, 3 to 4, and 5 to 6. So we can go ahead and conclude this now. We have our conclusion by conditional elimination, lines 2 to 7. We've successfully shown that what's called the left to right equivalency holds and the right to left equivalency holds, which is this here.